the setup and use of the house of pressure that we built here. We'll start out, taking the house out of the case and setting that up. We'll go through the parts of the house and then the props that come with the house and how to set those up. And then we'll go through some testing, just home performance testing like you would do on a regular house. And those tests are like blower door testing, zone pressures, where we're trying to find out where the air boundary is in the house. Does it line up with the insulation? Those types of things. We'll talk about pressure pan testing, which is testing that is done to determine duct leakage and help find those leaks. We'll talk about combustion appliance zone testing and backdrafting. Sometimes if our houses are tighter and we have everything from exhaust fans and all the forced air duct systems, those types of things can actually create problems to cause combustion appliances to backdraft. It can create a dangerous situation sometimes. So we'll do some testing related to that. We'll talk about room pressures, and those are when you have like a central heating or cooling system and you're closing your bedroom doors and those types of things, you're cutting off airflow to the return, and we'll talk about how those pressures affect the house and infiltration and just the test that you can do with house and making sure you have things set up when you're doing each test and things like that. So we'll start out with setting the house out of the case and setting it up, and then we'll go through the parts, and then we'll get into doing the testing. Okay, we're going to take the case off and set the house out. The case itself does have 4 wheels that are lockable, so if you're moving it and they have locks on all 4 wheels, you can lock those, to keep it from rolling. As far as opening the case, you have 4 latches, 2 on each side. You just twist those, and we'll set the case off. The 2 on the other side are already loose. The case has 2 handles on each side, and we'll pick up the case. You want to kind of keep it even. Sometimes you might have to kind of rock it back and forth a little bit, and then when you get it up to the top, we'll set it back over to the side. If you have a low ceiling, sometimes you might have to kind of tilt the case a little bit just to make sure that you clear the roof. So we'll start out with doing that. All right, now the case is off. The next thing we want to do, and actually probably one of the better things to do before you set the house up on the case a lot of times, is to put the chimneys in. They have, there's 3 chimneys. There's a longer one, which is for the water heater. There's a middle-sized one that's for a fireplace, and there's a really short one that's for the kitchen. And well, I have more detailed pictures of these as we go through the video, but it's easier to put these in now because you'll have to reach up on top of the case to do that if you wait till later. But the water heater one goes down in the first hole here, goes all the way down through the roof, through the attic here, and then down through the first floor. The second longest one, like I said, goes to the fireplace, which it goes to the opposite end. It just goes through the roof, through the attic floor, and then out on top of the fireplace. It fits right into a little hole there. And the last one is a tube that goes to the kitchen vent, and that just goes right through the roof, and there's a little place for it to sit in the attic that goes right to the kitchen fan. So once those are in, you can set the house up. And we're going to turn it around and have it backwards here. It does have, the wheels. They're nice. You can move this thing around pretty easily. Now, the way we're going to get it out of the case is the house has 2 handles, 1 on each side. They're really not big enough to pick the house all the way up and set it on top. So generally what we like to do is take the house out. We'll kind of catty corner it on the base, and then we'll get our hands under the base of the house, and then we can pick it up. Makes it a little bit easier. So we're going to take the handles and catty corner it, like that, and then we'll put our hands right underneath the base here, and then we're going to pick it up and set it on the top of the case. It's got little sliders on the bottom, so it'll move on the case pretty good. Sometimes I like to push it a little bit toward the back. That way, if I have props or like pencils or things, I can set those right on the ledge here. The case itself here, make sure sometimes those magnetic windows may come off and be laying in the case, and you can get those out. But any of the bags that the props come in, things like that, you could put in this case and either roll it under a table to the side, or just kind of push it out of the way and just kind of use it for storage. So I'll just slide it out of the way here, and then we'll get into going over the house and then the props that come with the house. Okay, we'll go over the parts of the house now, just mainly the rooms, and then I'll get into showing the different appliances and the controls. So we'll start out here in the lower part of the house here. On the left hand side here we have a garage. It's kind of like a tuck into the garage. We have a car that I put in there like a prop, and I actually even have a smoke generator that goes to that and simulates exhaust. And you can talk about those types of effects, as far as the garage is being connected to the house. I actually have even a door that goes between the garage and the basement here. And in the basement we have a forced air duct system, air handler. Basically it's just a fan in the box back here. That's connected to this red duct here, which is your return. Your return comes up into the house. It is a central return system, so you have one return. The green ducts here are supply ducts, and they are a duct in each room. These ducts actually have streamers on, so when we turn the furnace fan on, the streamers actually, you can see when the air is moving through that, and you can hear it now. The return duct here does have a leak in it, so it's basically a drain plug. We can make a leak in the return duct and show what happens to the pressures, in the different areas of the house. All these access doors are basically magnets with it's kind of like plastic windows, but they just peel off and you put them back on. They do have at the top of them, they have a label for each one of the rooms. Like this one says basement, there's one for garage, one for living room. So when you take those off, you'll know which room they go back on, and it's the writing's in the top left corner, so you know that's the top left of the window. Again, the supply duct comes on around. I'm going to turn the house here. I just have it on like a little turntable. It generally doesn't come with the house, but you can get one like a local department store. It's just a little table thing you can set it on. For the most part, when you're using the model, it's going to be sitting still, facing the front anyway, but this works good for showing it on the video. On the right hand side here, let me stick with my duct system for a minute. We have a supply leak here as well, so just like I did on the return, I can open this up and make a leak in the supply duct system. On the other end of the house there's one just like this. As far as the rest of this side goes, they are the controls on the house here, and I'll zoom in on those so we can get a better look. And we've got a close up on these. On the left side here, this is going to be a control for your furnace fan, and it's in the off position. If you turn it clockwise, that turns it on. When you first turn it on, that's full speed, and the more you turn it clockwise, the lower the speed gets. So I'll turn it on. See, the further I turn it clockwise, the slower this fan gets, and when I turn it backwards, it speeds up, and then finally it'll turn off. The next controls over from that are actually the fans. I have a kitchen fan, bathroom fan, and a dryer. So all the switches are right here. For the combustion appliances, we have a fireplace, a water heater, and a car exhaust. So when I get to those parts in the showing the house here, I'll reach my hand around and turn them on so you can see what happens when we turn each one of those on. The fans, they are lighted, so when I turn on the bathroom fan, a light comes on with that. Same thing with the kitchen fan and the dryer. Fireplace and the water heater, they each have lights. The car exhaust does not have a light, but it has a smoke generator, so when we turn that on, it'll look like smoke's coming out of the exhaust of the car. Next thing we have on this side of the house is the water heater. The water heater is contained in this tube. It has a light. It also has a smoke generator in that. While I'm here, I'm just going to show you how the water heater works, and then we'll do a little demo on the water heater. The water heater, it has that chimney that we installed when we first set the house up. Generally, you want that pipe within about an inch of the top of the water heater. When we're putting fluid in it, or sometimes when we're first starting it, it works better if the chimney's up just a little, so it helps start the draft a little bit better. The way that the smoke fluid, which I'll show you the smoke fluid goes in, is there is a small smoke generator that comes from a train set. It just goes right in the, you can see right there, it's pretty small. And that's pretty much the size of it, and it just fits right down in the top of this. The top of this has holes cut in it for the light to shine through. It's down in there. But this pretty much will just stay in the top of the water heater. There's really not much reason to pull it out. You can, if you're going to be moving the house and you want to take the smoke fluid back out, it might be easier to pick up on that sometimes. But I'll show you how the fluid goes in, and then if you want to take it back out, you can put the syringe back down in the smoke generator. Now, the smoke fluid, I have a small bottle here, then I have a larger bottle. This is Model Train smoke fluid. I've never really had a problem with it as far as smell or fire alarms or any of those types. I have a small bottle here, and then I have a refill bottle that I'll send with you, and that'll last you, a pretty good while. If you have any problems, if you ever run out of it, you can either give me a call. The place I get this is called Walthers, WALTHERS.com, and you have the information on the bottle when you get it. So if you ever do run out of it, you can call me, or you may be able to just get it directly from those folks. So you have that's big bottle, and then a small bottle here. You may just want, when you're doing training, just put it out in a small bottle and then refill it when you run out. And it comes with a syringe. I'll send a syringe with it, and the way it works, you just put it down in the bottle, obviously, and we'll turn this around here and get you a good close-up. And what I want is, when you fill those smoke generators up, you fill it up to about half a milliliter. There's 1 milliliter, then that's about the half mark. Then once that's filled up, we'll go and we'll insert that in the top of the smoke generator. In the water heater, or the fireplace, or the car, they all take the same and about the same amount. So once we've got that, we want to just take that, insert that right into the top of the water heater. I have put a little bend on this one, on the needle. You can do that as well. It makes it a little easier to get in there sometimes. You just squirt that right in there. And you can get too much in there, so if you do happen to get too much, it won't smoke right away. It kind of burns off a little, then it'll eventually start. But if you notice that, all you got to do to pull some of the fluid back out, or like I said before, maybe you're going to be moving the house and you're concerned that there's a little fluid in it and you don't want to worry about it getting out, you can just put that same syringe right back down in there, pull up on it, and it'll suck the fluid right back out. So it's probably pretty good practice just to do that. That half a milliliter will run you around 5 or 7 minutes, as far as the smoke coming out. So we'll go ahead and start this up. And I said sometimes it might be helpful to leave the chimney up a little, and then once it gets going, you can put the chimney back down. So I'm going to reach over and turn the water heater on. You can see right now, right away, that the light came on. And the next thing will happen is we'll get smoke coming out of the smoke generator itself. And here it goes. And sometimes it takes a minute for it to get going. But once it gets going, you can put that chimney back down on. It's always good to, before you do any session, or obviously to make sure these are working right before you demonstrate them, just to make sure that the chimneys are a little warm and the smoke generators are working good. You can see it works pretty well. And you can see the smoke with the light kind of gives it a, heats it up a little, so it gets a little better draft. And that goes all the way up and out of the chimney here. Okay, so now I'm going to turn this back off, and then we'll go over to the other side of the house. Okay, now we're on the back side. I've turned it around, and on the back side here we have a couple things. We have this access door here. This is actually just another one of those windows, which you can leave this on, and when you're doing combustion appliance zone testing, room pressures, those types of things, kinds of testing where you don't need the blower door installed. If you do want to do blower door testing and zones and that type, then the Duct Blaster, and I've got it basically set up with some bolts here where the Duct Blaster will fasten right to the house, and I'll show you that in a minute. The next thing that I have over here is the Fireplace. It's got an access panel, and we're going to get right to the back of the fireplace. Fireplace has a light in it similar to the water heater. The fireplace light, the way has a smoke generator attached right to the side of it. So that same smoke generator that's in the water heater is in the fireplace, but it just attaches right to the side of this. And then, so if you want to fill it up, you can just kind of turn the light around and get access to filling the smoke generator. Again, it's on Velcro here, so you can pull it loose if you want. Once you have filled it up, which I've already got some smoke in it, you'll just tilt the light back up and then twist the light around to where the smoke generator and the light point pretty close to straight up the chimney. Generally we'll turn the fireplace on without the access panel on, just to make sure that we got smoke going up the chimney. Get a little extra air to make sure it's got a good draft. So we have the light on, and now the smoke has came on, and make sure we got a good draft going, which we do. I'll turn that around so we can see it from the front side too. So you can actually see it's got a little light, and that light will shine through the front of the house. So we'll turn it back around. I'm back on the back side now, and you can actually put that cover back on the opening to the fireplace once it gets going. Sometimes you may need to leave it cracked just a little bit at the bottom so it gets a little better draft. The other things on the back side here is, this is actually the plug in here, and it's just got a, let me turn the fireplace off first. As you can just have an extension cord. It's also good maybe have your power strip, because when you do use the Duct Blaster for the blower door, you'll need that power supply as well. So a power strip usually works pretty good, but it's just got a plug, comes right out of the back side of the house here, so you can plug it right into the extension cord, which is what I've done now for this video. I'll plug it back up. Inside the house here, you may or may not be able to see it in the video, but there's two transformers that transform this line voltage, or like 120 voltage down to 12 volts. That's what all these appliances run on. Both of these transformers, they have two little lights on when you plug this up, and they have power. There's two little green lights that will light up. So that's your power supply to all your switches here. One other thing on the back down here near the bottom, this is your dryer. I'll turn it on. got a light in it. It will light up. You can see when I turn it on and off. It does have like a little cover here. This cover, you can use it like a damper if you want, and you can move it to the left or right to cover part of the hole. All of the fans, they do have speed controls, so you can adjust the speed of these flows, just like the furnace where it had the big switch. The dryer and the kitchen fan and the bathroom fan all have little speed controls. I'll give you a close-up on that in a minute, but it's basically just a little box, and you can speed that fan up. You may be able to hear it. But you can tell which fan's on by the light, so you'll know when you're doing a demonstration, and so will the people that are watching. They'll know which fans are on because they will light up. So I'll cover that back up. I'll turn that fan off, and then we'll switch to the left side here. Okay, we'll twist it on around. And on the left side here, you've seen the dryer in the last shot. And this is a side view of the garage and the bathroom here. The bathroom also has a fan. Here's that little box I was telling you about that you can use to adjust the flow. Step right here. You can actually, it's just got a little knob on there, and you can turn that. And that will adjust the flow of the fan. I'll turn the bathroom fan on and you'll be able to see it. See, it's actually lights up. And let me zoom in on that control. Right here. Take the access door off. Again, it's got a little cover on it. You can use it just kind of like a damper. You notice the more I move it out of the way, the more airflow you get. This little switch down here, again, will control the speed. I'll speed it up and down. And you can leave these, once you get them kind of set where you want them to show your pressures and backdrafting and those types of things, you really don't have to adjust them that much. So, you have the speed controller here, and then you can just turn them on and off with that switch over there. So, for the most part, once you use them, you don't have to turn them up and down, on the speed. You can just turn the switch on and off. Couple other things while I got this zoomed in here is there is a door, like I said, between each one of the rooms. And this has a little fishing string right here, and you can see when I pull on that, it opens the door between the room and the main body of the house where the living room and the fireplace is. And I have one of these in both rooms. And right below the handle on each side, there's a little screw, and you can just take the end of that line, which has got a loop in it, and hook it right over that screw, and that'll hold the door open when you're doing blower door testing or any type of test where you want to leave the door open. If you're not doing a test that requires that, or if it's just the house is just stationary and you're not going to use it maybe for a little while, it's better to leave those doors closed, just because they don't have any kind of a hinge or anything. It's just a magnet, and it's the way it's cut. It's better to leave them closed when you're not using the house, just so that it doesn't want to retain the shape of staying open. So that'll help it last a little longer for you. One other thing in these rooms, or in the bathroom rather, is it's like a passive vent. And what it is when you're talking about room pressures and those types of things, like when you're closing bedroom doors or bathroom doors or whatever, and you only have a supply in those rooms, you're pressurizing those rooms, and you're starving your return for air, you can use these vents to act like a passive return. So even though that the return is on the other side of the wall when the forced air system is on, and it wants the air that's coming out of this supply duct, it can still get it by pulling it through this passive return, which there's an opening just like this on the other side of the living room. If you take these off, then that allows air to pass through those. And we'll get into that when we talk about room pressures and doing some room pressure tests with the house. As far as the garage here, there is a car in the garage. Let me move to that. And in the garage here, you can see right on the back of the car is the smoke generator. It just has a piece of Velcro and it attaches right to the car. You can pull the car out from the front side of the garage if you want, or you can just leave the car in there. The car's not fastened, so it will come in the house and it'll just be in a bag. Generally I stick some type of car in all the models just so you can simulate this garage effect. This smoke generator right here has a piece of Velcro. It's a piece of Velcro on the back of the car, and you'll just fasten it right to it. You can put the smoke fluid, right in the smoke generator, and then reach right down in and fasten that right to the back of that car on the Velcro. And then when we, turn that smoke generator on, it'll look like the car actually starts up. I'll turn the smoke generator on. There's actually a few buttons, either in this case on top of the car, you can actually make the car startup sounds and those types of things. So when you start out your smoke generator and stuff.
Welcome, PT Cruiser operator.
And I'm going to turn the smoke generator on. You even have some nice music. Those types of things. But now you can see the smoke generator's on. So you can simulate things with the car exhaust. We can turn on bathroom fans, have return leaks in the basement, and you can actually simulate some of the leaks between the garage and the house and talk about those situations, and even use your manometer to measure some of the pressures. Sometimes what's kind of a cool effect is let the garage fill up with smoke and then turn on the bathroom fan in the room above it, and it'll actually start sucking the smoke from the garage, into the parts of the house from around the building cavities and those types of things. Also, I'll spin this on around just a little more here. Let that run for a minute. Is right here next to the garage, in between the basement, there is a little door here. And this door just has a handle, and you can open and close this door to connect the garage, to the basement. I'll zoom back out here and we'll look at some of these other access panels that I have. On the front here, there is one more access to the basement from the house, and that is right here is a little hatch that goes from the basement to the house. You can open and close that, so you can have connection between the basement and the house, kind of like a basement door. On the between the bathroom and the living room here, there's this wall has an opening at the bottom, kind of like a bypass. You can open and close that, as well as on the top of the house, on the top of the same wall, there's a bypass that you can open and close to make this wall open to the attic, and then you can get air coming in that. The next one over is a little slide for the attic hatch. I'll give you a close-up on that in the next shot, but that just opens up the same way. On the wall between the bedroom and the house, there's another one of these bypass accesses here, and you can open and close that. And the main difference between these two is this wall, you can use that same passive return to make leaks in the wall, and you can talk about convective loops. You can actually do a pressure in this wall and then run the blower door test, and your reading goes up when you have a bypass in this wall. On this wall over here, you may have a nice bypass into the attic, but if the wall is fairly airtight, you're not going to have much change in your blower door when you seal this. But it's still going to affect the energy use of the house, because you get convective loops where cold air will fall into this wall. This is open, and then it will heat up and just make a loop and go right back out. Whereas this wall over here, if it's got any type of holes between the house and the wall, and then the wall is connected to the attic, your blower door will actually be a lot larger, and you'll have a lot more heat loss from the house. But still, you can show the difference between having that convective loop and not. And sometimes that when you seal bypasses, you don't get a lot of blower door reduction because of that. So that's kind of a good thing to know and to show. I'm going to go and we'll zoom to the top and we'll look at the attic hatch and those bypasses. Okay, we're up on the, looking in the attic now. You have a couple of bypasses. This is the one over the bathroom wall. There's the same type right over the bedroom wall. And in the middle here, this is that attic access that you can open and close with this hatch. The roof itself, it just lifts up. And a cool thing about that is when you like move in the house from place to place or something, then you can store stuff in the top. And the way the roof is, it'll actually support itself. It'll hold itself up. And then when you want to let the roof back down, you just push up right in the center and it'll fall back down for you. So that's kind of what's on top. And I guess now we'll go into setting up the Duct Blaster to do the blower door test, and then we'll get into doing some testing. Okay, now we're going to get ready to put the Duct Blaster on so we can do blower door testing and those types of things, with zone pressures and pressure pans. And to do that, simulate the blower door, this house of pressure uses the Duct Blaster. Either you already have one or you got one when you got in the house. This fan is already set up to do that, and as I mentioned earlier, I have basically 4 bolts here. These bolts have wing nuts on them, and I could take those wing nuts off and then fasten the house right to it. The way I used to do this is I actually use the flex tube that comes with this and had it mounted to the house, but that's kind of cumbersome, so I've gotten to where I just set the Duct Blaster up to do the blower door test on the house. You can also just take these set up back apart and use it for a regular Duct Blaster on home, so you can still use this as your Duct Blaster as well. Now, the way I have all this fastened to the fan itself, the fan actually has 3 places here where you can actually drill through and put bolts in. If you notice, that's where the bolts are for the fan guard on the other side. So basically those are molded, and I'll just drill those out. There are 3 of those, 1, 2, 3, and after I have this kind of lined up, the ring, and then this square piece centered, then I'll drill all the way through both of those. I've put 3 bolts on each one of those holes, and then I put a lock nut or lock washer and nut just on the back side of that, so it'll be pretty secure. Then I've actually taken this and putting it right up to the house and made the holes to bolt it to the house. In most cases, I already have the bolts on there for you. If you're having a Duct Blaster and you need to fit it yourself, if you're having problems with it, you can give me a call. But basically, once that's set up, it'll just bolt right onto the house just in a matter of a couple of minutes. So I'll do that now. What I've already done is taken the wing nuts off of 3 of them here. I'll take off the 4th one. They'll just spin right off. You want to take that cover off, of the door, and just lay it out to the side. And again, they're marked, at the top. This one says blower door, so I'll just, when you're done, you take the fan off, you put it right back on. So we want to put this on the house. We want to set it over each one of these bolts, and it'll match right up. Oh, it does have the top marked for you, and it'll probably only fit one way. So the top, and you want to just turn that around to where that it matches up to the bolts, and it'll slip right on. And you want to take those wing nuts, put those right back on, and it's probably best to start each one of those and then tighten them up. So that way it goes on a little bit easier. I'll go ahead and start the next one here. But basically you just put all those on and you tighten them up. And that takes, a couple minutes to do that. Now, once you get all the bolts on, you want to hook up the speed controller and the hose to that. The speed controller basically just hooks right up on the fan here. You have your speed controller plugs in on the top, and then your hose to read your flow plugs right onto this port, and that goes down, you know, to the inside of the inlet of the fan where the it picks up the fan pressure. So you would hook those two on, then you'd be ready to go. Okay, I have gone ahead and tightened up the 4 wing nuts. I attached the speed controller right onto the fan. I attached my hose to read the flow right onto the port on the fan as well. And plug the speed controller in. Once that's in, you can kind of check it out. Just turn the speed controller up. And it'll work just like a blower door. It's got speed control here. If you have an APT, you can actually set this up to run from your APT and your laptop computer. If you do that, you'll want to get the speed controller on the Duct Blaster set up to where it will work with the APT. It's basically just a little telephone jack that plugs in to that, and it runs to your APT and your computer, so you can actually have it run the Duct Blaster, you know, to do the blower door test and keep the house at 50 and all those good things. So, you know, that's the next step. You know, if you get using the model and you get to doing a lot of training with it, then it may be helpful, you know, to go to that level. So we finished getting the Duct Blaster fan on. We'll turn the house back around and we'll get the manometer set up, and we'll start doing some the blower door test. Now we've got the Duct Blaster set up. We've got our hose hooked up and our power cord hooked to that. We're going to go ahead and do a simulated blower door test on the model here. And what we need to do that is a digital manometer. You may already have a digital manometer. Maybe this type right here, where it has 2 channels, and if you turn that on, it'll read pressure and flow and all those things. But it gives you a reading right across the screen here. You have an A side and a B side. It's basically on this knob here. You can switch between reading one side or the other. Here are the 2 sides. This is the A and this is the B. So it's like having 2 manometers in one. On the A side here, you have these 2 ports. One says input and one says reference. So, and what this is if when you're measuring a pressure or pressure difference from one place to another, you will have one on the input and one on the reference. And when you do a blower door test, the typical way that you do that is you measure the house pressure with reference to the outdoor pressure. And you do that by running a hose to the outdoors. So when you turn on the fan, you're measuring the depressurization of the house. And typically, you get that to 50 pascals. 50 pascals is pretty much the standard for doing blower door test. It's a metric unit of the pressure. The pascals is a 20 mile an hour wind is about equivalent to a 50 pascal pressure. So when you're doing a blower door or explaining a blower door to someone or a homeowner, you can say it's about like putting a 20 mile an hour wind on all 4 sides of the home at the same time. In effect, that's what's going on, is the blower door is sucking air out of the house. Anywhere there's holes, air is going to be pulled in. This digital gauge gives us a way to measure that airflow that's coming through all those holes. So on the A side, we want to measure that house pressure with reference to the outdoors. Typically when you do the blower door, you're on the inside of the house. The fan is on the inside of the house. So you would have on the A side, you'd be measuring house pressure with reference to the outdoors. So if you were inside the house, you would just add a green hose, or a, green hose is typically used just because green's grass, I guess, and it goes outside. But anyway, it would hook to a hose. It would go to the outdoors. So we'll be measuring house pressure with reference to the outdoors. Like I said, that's if you're inside the house and the fan's inside the house. So, the way this works usually on the house is I do this from on the outside of the house, at least the blower door test part. The zone pressures and pressure pans will actually do that. We'll set that up from the inside. But for doing a blower door test, we want to measure house pressure with reference to the outdoors using a digital gauge. We would put the hose on the top because we're on the outside, and then run the hose in to the house. Along the house here, there are several holes, like into each room and into the attic, the basement, garage, all those places, so you can run hoses in, to, and out of, and measure the pressures. If I wanted to measure the pressure, house with reference to outdoors, since I'm on the outside, I would just run the hose in the house like that. And then when I run the blower door, that will give me the house pressure. On the other side of that gauge, the B side of your manometer, you want to run the hose to your fan. And that just goes right to that port and to measure the fan flow. When you set your digital gauge up, you want to set it up to where it will read Duct Blaster flow. And we are using a Duct Blaster, and we are using ring 2. If you have the older model digital gauge, what you'll want to do is go down to fan select, which is at the very bottom. I'll come over a little closer where you can see it. You go down to fan select, which is down here at the very, very bottom. You will push up on this little toggle switch till you see 8. That stands for the Duct Blaster. Once you get to that point, you can pull down on this same toggle switch. That will give you 2, and 2 is for the second ring, so 8-2 is for the Duct Blaster with the second ring in. So that way, when we want to go and read flow, we'll get the blower up to 50, we can move the knob down to flow, and we'll take the reading, and that'll give us the blower door reading for the house. So we'll do that, and then I'll also show you the newest manometer that's come out, and that's probably the one that we'll use for the rest of the testing. But I'll show you the older one too, just in case that's the one that you have. So we'll set this up. We'll run our hose from our fan to here. We're already set up on 8-2 to measure our flow. And what I'm going to do is I want to be on the A side with my knob. I want my mode knob to be on pressure. And my hose is set up on the inside. You have all of your exterior windows and doors closed, so all your windows are on. Your interior doors are open, so you want to use that little string on the side and attach that so that the interior doors stay open. And like I said, all the other exterior doors and windows are closed. And you can, if you have more than one person, you've got more than one manometer, you can actually tee off on this red hose that goes to the Duct Blaster fan, because there are several holes in the front of this house. You could actually use that for the A side of measuring your house pressure. So you could actually have several people do demo on doing the blower door and learning how to use the digital gauge and doing that test. So now we're set up, we're ready to go. We want to, like I said, on pressure, channel A, and I'm going to turn the speed control up until I get to 50 pascals on this gauge. Put that on whole numbers. It's got a little switch. You can switch between decimals and whole numbers. I'm just going to put it on whole numbers. And once I get that to 50, then I want to flip this over to B. Then when I'm on B, I want to go down to flow. And you can actually see the blower door reading. It's about 160 CFM. That's the leakage through all the holes throughout the house. So all these little holes, the amount of air coming through those are equivalent to 160 CFM. So on a standard house, you're probably looking at 1,200 to 5,000 CFM, depending on the leakiness of the house and the age and those types of things. Newer, tighter houses will probably be less than 1,200. But this is a smaller house, and 164 CFM. That's the leakage throughout this model here. I will show you the other gauge next. I'm going to turn the blower door off. I'm going to take my hoses loose, and we'll set up the newer gauge. This gauge is called the DG700, and it's made by the Energy Conservatory as well as the other one. The other one is called DG3. This one also has 2 channels, an A and a B. And the difference is, on this you can see both channels at the same time. You can see the A side and the B side. And you just have an on and off switch here that turns it on and off. and you actually have a little light. If you need a light, you can turn the light on. And so you don't have to do that switching around between A and the B. So it works really well with the model because you're not having to take your hand and stick it into the house and switch from A channel to B channel. You can just kind of keep rolling and be measuring both of those at the same time. To do the blower door test with the Duct Blaster, just kind of the same steps. We want to set it up for which fan that we have and the rings that we have. And the way we want to do that, first of all, is what mode do we want. And one of the cool things about this is you can actually set this up to where it'll, do your CFM 50. You don't have to do like can't reach 50 factors and all that stuff. So you can actually push mode on here. And on the left side here, it'll say pascals and then CFM. You can even have it say CFM 50. So when you're within about 5 pascals of 50, whether that be like 45 or 55, you're within about 1% accuracy. So you're not having to worry so much about getting it to stick right on 50 a lot of times because it's actually set up to calculate that for you. So on the A side, it'll read the house pressure. On the B side, it's going to read our flow at CFM 50. So as soon as we start getting a house pressure, it'll start giving us some flow readings, what it would be at 50. And then the closer we get to 50, the little more accurate that's going to be. Now, we want to pick what device we're using. Right now, it's set up to read blower door 3. And we want to use our Duct Blaster. And most of you that have newer Duct Blasters, those are going to be what's called Duct Blaster Model B. And so we've got that set up. It says DBB, as in boy, Duct Blaster B. Now, over here on the B side, we want the setup configuration. And that is, we have 2 rings in. And those are listed as A1 and B2, C3. So if you have numbers or letters on your rings, then you must match that up. And we have ring 2. So we want to hit our configuration button until we get to where it says 2, which it also says B, because sometimes those second rings are labeled B. So now we're set up. We're set up to read pascals on A, which we're going to get our 50. Where we're going to read our CFM 50 on B. We got our device set up for the Duct Blaster B, and we have our configuration set up for the second ring. So you can actually see all those settings at once. You're not having to use a knob to go and see what you have your settings set on. So that's kind of another neat feature as well. So I'm going to back up. I'll set that up just like we did for the other gauge. We'll put the house pressure with reference to the outdoors on channel A. And on channel B, we're going to put the fan flow. Now, and we'll just turn that back up to 50 and we'll get our reading again. Hopefully you can see this on here. And I'll get a little bit closer. And I'll get that up to 50. You can see it starts giving us a flow reading right away. So the closer I get to 50, the little more accurate that's going to get. So I'll back it down. So I get to 50. And like I said, I don't have to worry so much about getting the gauge to stick right at 50. Our hose came out, so now I got it back in. So our reading here is about 156. So it's pretty similar to the other gauge. They're reading pretty close. I mean, they're within 3 CFM. And that's the reading. It's not much more to it than that. You can, make leaks in the house, like simulate blower door or making a leak in your house. Just open the window a little bit, and you see how it changed the house pressure here. And when I made that leak, so in other words, to get the new blower door, we'll have to speed it up to get it back up to 50. Tell us what our leakage is now. Again, I don't have to worry too much about getting it right on 50, especially with this gauge. So it's right at 200 CFM, whereas before it's about 157. So we've jumped close to 50 CFM just by making that little crack in the window. So you can show that type, by making a leak and then sealing the leak up. You can have different folks come up, if it's a hands-on type class, and change the house around a little bit so people don't get the same readings. They'll have to kind of go through the modes and do the tests for themselves and come up with their reading. One other thing you can use when you're talking about the blower door test is a little smoke puffer. You can get these at several different places. If you need to know where to get one, give me a buzz. They're generally anywhere from 35 to 50 bucks. It just has a little smoke, and what you can do is you can show how when you use the blower door test, it actually sucks the smoke right in the house. If I puff it and have a leak here, it's going to pull air in. If I have a leak in the basement, I mean, anywhere I puff the smoke, air is going to be pulled in because that fan's depressurizing the whole house. So that's another little cool thing to have. It makes things a little more visual. So I'm going to turn the fan off. And then we're going to set the gauge up to do zone testing and a little bit of pressure pan. So we'll just show you how to do the setup for each one of those, not so much the whole story of how to do zone test and all that, but at least how to set it up and do the pressures on the model here. One of the things that I use, or prop that'll come with the house, is basically a little stand for the manometer. When we set the stand in the house and use the gauge, then you can just set it right down in that gauge, the gauge right in the holder here, and it'll set right in the house. So when you're doing your testing and stuff, the gauge will be set up so you can actually see that. What works well sometimes if you have more than 5 or 10 people is using a camcorder just like this. You can hook it to an LCD and you can actually project these readings right on the big screen. So that works pretty well too. What we're going to do now is we're going to set this up to do a zone test, or at least talk about zone testing, and then we'll do a couple. And now that the model is inside, or the gauge is inside the house, we still want to measure house pressure with reference to outdoors. And I'm going to hook that up just like this. Since we're on the inside now, we're going to leave the top port open, and the bottom port will go to the outdoors. It's just got a little green hose that goes to the outdoors, and another hose on the B side so we can measure the pressure. And the way we'll do that is we'll just add that to the top input, and then we can use this hose to measure pressures in different zones. It could be the attic, could be the basement, could be the garage, to find out how well those spaces are connected to each other. And we're trying to find where the air barrier is. We can find the insulation or the thermal boundary by looking around and seeing where the insulation is. And ideally, the pressure boundary should line up with that thermal boundary. And we can find the pressure boundary by using the zone test to find out if they're in the same place. So I'm just going to explain a little bit of basics on zone, and then we'll do a couple attic zonals and basement, and maybe one in the garage and the wall, so you kind of get the theory on how to do the zone test. I mean, there's a lot more to it than what I'll be covering here, but this is basically the setup so that you can how to use it with the house. So I'm going to turn the blower door on to 50, put the window on, and I'm going to stick this hose, my zone hose, to the outside just for a moment to start out with. So, got my window back on, I'm going to get it up to 50. They're both reading pascals. A channel and B channel are both reading pascals. And again, the easiest way to get pascals is just turn the gauge off and then back on, then you can read pascals on both channels, so we can see A and B at the same time. As you can see right now, they're both reading 50 pascals, and that's our house pressure. And on the B side, it's basically the same thing because we're sticking the hose outdoor. The blower doors are 50, so it should be reading basically the same thing. If I take this hose and stick it out on the wall on the other side or on the back of the house, it should be relatively the same. It should be about 50 pascals. So anywhere we stick that hose outdoors, it should read about 50 pascals. Now, I'm going to take the same hose and I'm going to pull it out and lay it inside the house. Just going to pull it out as We'll lay right inside the house here. Door back on. Now what happens to the pressure? The pressure now reads 0, like 0.8. So because it's in the same space, it's inside the top port and the bottom port, they're going to the same place, the input and reference. So there's no pressure difference. So if you think about, anything that's inside is going to be closer to 0, anything outside is going to be closer to 50. So let's think about your attic for a minute. Your attic should be what? It should be air sealed. Between the house and the attic, you don't want to be paying to heat and cool your attic, so you want a good air seal. That's generally where your insulation is on the ceiling here on the attic. So you want a good air seal in the same place. If they're not in the same place, then you can have problems heating and cooling the house. So all I'm going to do is I'm going to take that same hose that I got laying in the house, I'm going to stick it into the attic. We're going to measure the pressure. So if we think we've got an air seal here, and our attic is ventilated to the outdoors. I have attic vents in the attic, so it should be like outdoors. And we said that outdoors reading should be closer to 50, so when we stick our hose in the attic, it should read closer to 50 on our gauge. So all I'm going to do is I'm going to take that hose, I've got a hole in the attic right here, and I'm just going to run that right up through here. Put it back on. But anyway, you can see that the attic, on the B side again, is roughly the same pressure as the house pressure with the blower door. So that's telling us that the attic has got a pretty good air seal. It's sealed off from the rest of the house. Let's say that I went and opened the attic hatch, or I made a bypass. I've got an attic hatch right here, and we'll just see what happens to the pressure in the attic. So I open it up. Immediately the house pressure and the attic pressure drop because I made a big hole in that barrier. So let me just close it off part of the way here. So, and I'll turn my blower door back up to 50. But when we were at 50 before, we were pretty much the same in the attic. Now we're less than that. We're like 44, 43. So that tells us that our air barrier between the attic and house is not quite as good. Where I opened that attic hatch, so we're leaking air, heat, moisture from the house into the attic. Might not be a direct leak like my hatch there. It could be, smaller leaks for plumbing chases and duct chases, any of those types of things that go into the attic. You can get, air and heat and moisture can be transported with that. So that's a good way to find out where that air barrier is. If I stick it in the attic and I get a 10, that tells me that I've got some, I've checked my gauge first, but it tells me that I've got a lot of holes between the house and the attic. Could be that you have a drop ceiling, could be, that the old ceiling is out, but there's definitely, not an air barrier between the house and the attic. But that gives you an idea of where that barrier is. So what I'm going to do now is I'll take it out of the attic hatch and then put it into the wall. One more thing about on the attic is it's typically good just to get up in the attic where you can do the blower door and look around, find your insulation, and just do a visual for bypasses. And when you come out, just bring you a extra hose and drop it down through the attic hatch, if you have one there. And so when you do your blower door, you can just hop over right on this hose and do your attic door. So let's say we want to do one in the basement. All we're going to do is take that same hose, put it right into the basement. We can read the pressure in the basement. Right now the pressure in our basement is 27, and that's right in the middle. So where's our air barrier? Is it not the floor between the house and the basement, or is it the basement walls outdoors? Right now it's about the same. You got about the same amount of leakage between the two. So we need to make a decision. Generally, if you have a basement, you want to, in most areas of the country, you bring them inside. If you have ductwork and water lines and all that stuff, if you were to air seal
the exterior walls of the basement. Maybe you got some broken out glass, maybe a door doesn't seal good or a window. You can seal those things up, seal around the rim joist, any of those things that are letting air from the outside into the basement. If you bring the basement more to the inside, in other words, closer to zero, then you won't have to worry about wrapping the water lines or wrapping the ductwork, you know, and even duct leakage isn't going to be near as important if it's in a conditioned space. So it gives you an idea of where, you know, that zone is or where that pressure boundary is. So it gives you, you know, kind of a target as to what you want to do. And then if you go and start sealing those outside walls, then it should be start coming down closer to zero. So you can kind of find out where you're at, do some work, and then take another test to see how you've done. I'm going to take the same hose again, and this time I'm going to put it in my garage. I'm going to leave it kind of zoomed in here so you can see the readings on the gauge. All I'm going to do is take the hose that's going down in the basement, I'm going to put it in the garage where my car is. I do that. I got a little hole over here. Alright. It's in the garage. Right now the garage is, again, it's about the same as the basement. It's like 26. So let's say that I open the garage and make it a little bit leakier to the outdoors. Then the pressure in that garage goes a lot closer to the outdoors. All I'm doing is just opening a window here right where the garage door is. You can see my finger right down here. I'm opening that now. So I closed it back. It's about 26 again. So now let's say that I want to, I got a little bypass between the house and the garage. You know, on this wall we talked about, I had those passive vents. I've got one of those passive vents open in this wall between the house, the main living room, and the wall. And I'm going to make an opening in the bottom of that wall between the wall and the garage, and we'll see what happens with the pressure in that garage. Right now it's about 22. I'm going to open this up. When I open that, now the pressure in the garage is going down closer to zero. It's like 15. So now our garage is getting a lot closer to the indoors. And if you have a garage and you read a pressure, let's say 10, that's telling you that basically your car is sitting right in the living room, and that you don't have a very good air seal between the garage and the house. So you want to make sure, if that's going to stay a garage, that you isolate that from the rest of the living space, because you don't want carbon monoxide, you know, anything that you have in that garage, you really don't want it coming in the house, the fumes and odors. So you want a good air seal, and also insulated, so you want a good pressure and thermal boundary in those areas. So that's important, especially when you have tucked under garages and attached garages, that you want those to be separated from the house. What I'm going to do now is I'm going to measure pressure in the wall. I'm going to take the same hose, again, the same hose I've been using before. Like we said, 50 was closer to the outside, 0 is closer to the inside. I'm measuring attic, whatever the zone is with reference to the house. Now, if I take this hose and stick it in the wall here, just an interior wall now, it's reading about 1.8. So right now that wall is almost totally indoors. There's not much leakage, you know, to the attic or outside. So the interior wall is actually inside. Let's say that I reach up here and open the bypass right here. It goes into the attic. I'm going to open this and see what happens with the pressure in the wall and even the pressure in the house. And when I did that, now the pressure in the wall went from, you know, 1 like 19, but my house pressure also dropped. So to get the house back to 50, I need to speed the fan up. Now I've got the house around 50. That wall now pressure is around, you know, somewhere in the middle, 23, 24, bouncing around a little bit. But anyway, the idea is, if you got leakage in that wall, when I opened that bypass, my blower actually increased when I made that leakage and made my wall go more to the outdoors. mean, sometimes you'll be walking through a house and you'll have like a interior light switch might be leaking a lot of air, and you can measure the pressure in that wall. The easy thing to me to do is just take a pressure pan. I have one sitting right here, and just hook it to that hose. You can put it right over a light switch or anything that basically you wanted to measure pressure on, so you wouldn't have to make a hole in the wall. If you don't have something like that, you can make a hole. Toothpaste seals the hole up pretty good when you make it. If you need to do that, but you don't really need to make a hole in every wall. It's just maybe if you get a lot of air out of a wall somewhere and you want to check that out, you can put the test on it. See if you get a high number. If you do, then maybe you can find out where the air is coming in. And it's probably not necessarily the light switch that's leaking. It's probably air coming in from the attic or underneath the house where you're getting connection into that wall, and you want to address that by sealing it. I mean, I've had walls where they're interior walls, a lot of air coming out of the light switch has been connected to bathtub that's on the other side of the wall, and that bathtub had a hole under it, and the hole was connected to the crawl space. The crawl space was connected to the outdoor, so the air was coming up through the crawl space, under the tub, into the wall, up the wall, and then out the light switch. And I was reading like 43 on that particular house, and then we went down and sealed under the tub and reduced that pressure in the wall from like 43 to 3 and brought that wall, indoors where it should be. The biggest places you want to check for zones would be like attics, crawl spaces, garages, those types of things. When you're doing a zone test, it's basically just giving you a ratio. If you get a reading of 25, it's telling you, for instance, on the attic, it's telling you that the hole between the attic and the house is the same size as the hole between the attic and the outdoors. It doesn't necessarily tell you if the hole is this big or 5 times that size, but it's telling you that they're the same. They are, advanced zone testing where you can actually take a zone reading and then in your blower door reading, and then open that zone either to the house or to the outdoors. Retake your zone reading and your blower door, because it's going to change when you make the hole, and then you can run that through a little calculation. It will give you an estimate of the hole size and the CFM leakage or reduction that you can expect if you seal all the holes between the house and that zone. So there is, a little more level to take it to. This will give you the basics part of it. If you have, taken some sessions on zonals and things and read up on it, then you can start maybe incorporating some of these things into the house as well. I feel that they'll work pretty well on this house because they do have bypasses and attic hatches and stuff where you can do even those types of tests. Another place would be garages. That would be real important to know how big that hole is between the garage and the house. So that'd be another place you could want to do that. So, that's pretty much the zone. You're just putting a hose on and you can measure different parts of the house and see where they're inside or outside. And again, you want to see if the thermal and your insulation thermal boundary lines up with your pressure boundary. So even if you have insulation, across this bypass, if this is open to the attic and there's insulation across it, it's not going to be doing a very good job because it's not an air barrier there. The insulation is just going to act more like a filter, and it will maybe slow the air down a little bit. Most of the time you're just going to see dirty or sooty looking insulation, and if you pull that back, most all the times you're going to see some type of hole that goes down into the house. It could be, like I said, plumbing, duct, any kind of chases. They have soffits, bookcases built in, stairwells, all kinds of things that just basically open up that plane or that level of the attic to other parts of the house, whether it be interior walls and things, places where air and stuff can move right up and get into the attic space where you're losing your conditioned air. The next thing we're going to do is do a little bit of pressure pan testing. So I'll set up for that, and then we'll do pressure pans, and then we'll get into a little more on duct leakage, and then maybe some room pressures and combustion appliance zone. Okay, now we're going to do some pressure pan testing. like I showed you before, a typical pressure pan looks something like this. It's basically just a plastic pan with a rubber gasket on it. And it's got a little pressure tap. That can be hooked to a hose. And you can, when it started out, these things were cake pans and just had foam tape on them and drilled a hole in them, put a little tap hooked to your hose. And basically what we're doing is a zone test on the ductwork. And we said before, 50 was like outdoors and 0 was like indoors. So if we think about our duct system, it circulates supposedly indoor air. We want, that to be our indoor air that's heated and cooled. We don't want to be bringing in air from the outdoors that we have to heat and cool along with all the other, stuff that you bring in with it. You want to have a good tight duct system. There are ways to do this test, the pressure pan test. And what I've done is just made a little cut and put a little pressure tap on it myself here. And what we'll do with that is we'll hook it up to that same yellow hose that we was doing the zone test with, and we'll put it over one of the supply vents. I'll just do one for an example. But if you were doing a real house, you would just start at the blower door and go clockwise around the house, and you put that over each one of the supply and return registers. And like I said, the closer to 0, the tighter the duct is, and the closer to 50, the leakier the duct is. There's some other things that you need to know is like, if your duct is in the basement and your zone pressure in your basement is only like 25, and even if the duct was connected, the leakage reading you would get would be 25. And there are ways to alleviate that so you get an accurate reading. If you go through your pressure pan book, if you have a pressure pan book from the Energy Conservatory, that'll give you details on it. Basically, this will give you a quick and dirty. If there's leakage near this register, it will tell you. If I got one register that reached 2 and I got another register that reached 12, then that's going to be, the one at 12 is going to be the higher leakage. Same thing goes if you got one that's a lot leakier than some of the other ones. You start sealing there first, because ideally, this finds leakage, pretty close to the register, whatever you're measuring. But if there is a really big leak somewhere else in the system, it will telegraph, or it will show up, on the other readings. So if you start out with the big leaks first and then work your way, to the smaller ones, then ideally you would like to get all those readings, less than 1.0, which on a scale of 50, that's very, very small. So I'm going to set this up. Again, this is done with the blower door on. You've done your blower door reading, you've done your zone test. Now you're just going to the next step is doing the pressure pan. Same setup. All the interior doors are open, exterior doors and windows are closed. You're measuring house pressure with reference to the outdoors. On the A side, you want to get to 50, and on the B side, I'm just going to put this pan on there, and we're going to measure the pressure in the ductwork. So all I'm going to do is take this hose, I'm going to put it right on the end of my cup, and I'm going to put this over the supply register right here in the living room. So all I did is sit it right over it. I'm going to put the window back on, I'm going to turn it up, turn the blower door up, get it to 50. Okay. Now I've got it over that pressure pan. Right now it reads basically 0.6. That's like totally indoors. It's well sealed. It's not much leakage at all, if any. And it's a pretty good system. Now let's say that I have a leak in the supply. This is where you can go in and open one of the supply leaks, on either side, or even a return leak. Because ideally you want to do a pressure pan on all the returns, when you're at a house. But just to simulate it, you can open one of the 3, and you can see how it changes the readings on your manometer. So I'm going to do that. I'm going to go to the one on the bedroom side or right-hand side. I'm going to open that. You can see how it changes the reading. Actually, when I did that, because the leak was to the outdoors, my house pressure even dropped. Once I get that back to 50 there a little bit, our reading now is actually went from like less than 1 to over 12. So just by making this little leak, it changed that much. So I'm going to plug this back in, and then it should go back down. So it went back down, and the house pressure went back up. We still leaks in the duct. The duct was leaking to the outdoors, so it's kind of like air leakage, right? Except it's a lot worse on a duct system because you have a bigger driving force. You have a big fan. So if I had that same size hole to the outdoors versus, through the wall versus one in the duct side, that same size to the outdoors, then obviously that one to the duct's going to be a lot more important because it's got a lot higher pressure and we're pulling in more air. So, and when you're air sealing a house, ducts are just as, or more important than other things a lot of times because of that driving force. So, and when you're doing air sealing, you want to take duct leakage definitely into effect because it can make a big difference, in the air leakage of the house. And the fuel bills and safety and all those issues. So, that's how you do a pressure pan. Next thing we're going to do is we're going to set up for do CAS tests and talk about a little more about duct leakage. Those tests will be done with the Duct Blaster off, and when that fan is off, we actually want it covered. The Duct Blaster has a cover that goes to it. It's just like a little cover here. It looks like a shower cap, and basically it just fits over right on the back of the fan. So when we're doing this test, we don't have to take the Duct Blaster off. We can just cover it up. Just if you do go back to doing blower doors or whatever, later, you got to remember to take this off. Sometimes you'll forget and you'll say, what's wrong when you left that on. So I'm going to set that up, then we'll get ready to talk a little more about duct leakage and some backgrafting issues, and we'll go from there. Okay, I got this set up. We're going to talk a little bit about duct leakage now. The way I had the manometer set up is have actually both the channels now set up to measure with reference to the outdoors. I'll pick this up here. You can see through the screen here on the front of the glass here on the house that I made a little T connection so that when I have the hose ran to the outdoors, I can actually measure with reference to the outdoors from the same hose without having to run a separate hose for each reference port. So, and what I'm going to do on the A side, I'm going to leave the top port open. That's going to measure the pressure in the house, or the main part of the house, with reference to the outdoors. On the B side, I put another hose into the basement to measure the pressure in the basement. Again, because it's teed to that hose to the outdoors, so it's measuring basement with reference to the outdoors. And what we're going to do is we're going to turn on the furnace fan and see how it affects the pressures. And then we're going to make some duct leaks, with the supply and return leaks that I have in the duct system. We're going to see what happens to the pressures in the house. And then, and at the same time, I'll even be running the fireplace and the water heater so that we can see how it affects them as well. Ideally, when you turn the furnace on in any house, you can either turn on the air handler, or in some cases you may actually have to turn on the furnace to get the fan on. You want the pressures to be fairly even, with as far as the main part of the house. With reference to the outdoors. When that fan comes on, it shouldn't really go a large amount to positive or negative. If so, then it shows that you got some leakage on one side or the other. And we'll talk about what that positive and negative means, when you get a reading of that with main body with reference to the outdoors. So first of all, we'll turn on the fireplace and the water heater, make sure those are going good. And then I'm going to fire up the furnace fan and see how it affects the pressures. And then we'll not only watch the pressures, but we'll watch the fireplace and the water heater. I do have it zoomed out a little more than I did before, so we can see the water heater, which is down here in the basement. We should be able to see that, and the fireplace chimney, and hopefully the numbers all at the same time. I'll read the numbers out, so it's not terribly important. I think it's more important that you can see the house and the way it's set up here. So I'm going to check out the fireplace and the water heater first. Alright, both of those came on. You can see the water heater down here in the bottom right, the little light, and then the fireplace, it come on too. So the fireplace is on, it's smoking, the water heater on, and it's smoking now. So both of them are working. Both the fireplace and the water heater, they have good draft. And the smoke is going out for both of these appliances. Now, I'm going to turn on the furnace fan. First I'm going to put this window back on again. The setup is we have all the exterior windows and doors closed. Right now all the interior doors are open. So we're going to turn on the furnace fan and see what happens, mainly to that pressure on the A channel house, with reference to the outside first. Okay, we've done that on this A side here, and it's like 0.1. So it's basically 0, is no major pressure difference here. Our fireplace and our water heater are working. The water heater is having a little trouble. Sometimes you might have to mess with them a little bit to make sure you got your draft going good, or it might require, even sometimes cracking a window in different parts of the zones to show the pressures that you want. So, it's going to require sometimes a little bit of playing around with to get it to show exactly what you want. But I ended up making a little crack in that where the basement window is for the supply leak, so it let a little more air into that where that water heater is, so it drafted a little better. Kind of like what I did with the fireplace. I left. Sometimes I'll leave it opening up just a little bit, so it gets a little extra air, so it drafts just a little bit better. Okay, so they're both going. The pressure is actually it's 0.1 right now, so it's pretty even. Now the other hose is going into the basement, so it's measuring pressure in the basement at the same time, and I'll talk about that as to why we can measure both those pressures at once to see what happens when we make leaks in both of those places at the same time. So I'm going to make a leak in the supply duct over here on the side. You can see my hand. I'm going to make a leak in this duct, and we're going to watch what happens to the pressure. But I also want you to watch what happens to the fireplace with the smoke. I'm going to do that, and I'll probably do it a couple of times because you watch all 4 of those things, the 2 pressures and the 2 chimneys. So here we go. So all the smoke from the fireplace is now coming in. It's coming in so much you can't even see it now. The house is like negative 1.3. Again, these fireplaces, they don't have as much heat as an actual fireplace, so it takes a little less to backdraft it. The water heater, you can see it over here in the back corner. It's just chugging, and because it's actually under positive pressure in the basement. So when I made that supply leak, it's not balanced anymore. I have more air being blown into the basement, than there was any before. In the house, there's more return air. The return is still looking for the air that was coming out of the supply leak I made. Basically, I cut off the airflow to this duct when I made a leak there. So now there's more air as far as the house, the main part of the house. There's more air being pulled into the return than there is coming out of the supplies, because part of that's now leaking in the basement. That's why the main part of the house went negative, which is like -1. So if we have a supply leak, then we turn on the furnace fan, we measure the house with reference to the outdoors, we get a negative number. So if you get a negative number, it's telling you that the supply side is leaking the most. In the basement here, because the basement is fairly tight, we got a positive number. It's actually helping that water heater draft. So in that case, it's actually helping it a little bit. So I'm going to plug the leak up. You can watch the fireplace and the water heater. Fireplace should start drafting again as soon as I plug this up. It should turn around. May take it a second. There it goes. So it took off. The water heater's still working and the fireplace are still working, and the pressure's evened out again. Now, I'm going to do just the opposite. Now I'm going to take a return leak. I'm going to open the door here. The return leak is down here in the basement. I'm going to open this up, and we're going to watch the fireplace and the pressure readings. We'll see what happens to the fireplace and the pressure in the house. The fireplace just really took off, and the pressure went from basically 0 to positive. I'm going to do it again. As soon as I open it up, that fireplace just really took off. So now it's blowing all the smoke out. If you look in the basement, you see all the kind of like little puffs that was coming down the chimney into the basement. The reading on the basement is now negative, and the reading in upstairs is positive. So, plug it back up. the water heater will start drafting again. So does the fireplace. They run a little low on smoke. You know, if you want to fill them up right before you do the test, it's a good plan. But when we did that return leak in the basement, I'm going to do it again. Just look at the pressures this time, since the smoke's about out. The main part of the pressure in the house on channel A, house's pressure to the outside it's positive. It's positive 3 now. And so that's because we're getting more air blown into the house than we are return air. Just the opposite of what was going on before. It's not balanced anymore, this time it's just balanced in the other direction. So this part of the house is actually pressurized. It's actually helping push the smoke out the fireplace. So, you know, the return leak here in the basement, it's actually about -3 in the basement now. So the water heater is backdrafting. Not only that, anything that's near that return leak, whether it be paint fumes, gasoline, anything that's in that basement can be pulled into that return. If that return is in the attic, it could be pulling in, if it's the summertime, it could be pulling in 150-degree air. It's not going to be very efficient for a cooling system, air conditioning system, to be pulling in 150-degree air and trying to cool that down. Not to mention insulation and those types of things that can be pulled in to the house. You know, so you can definitely increase, you know, everything from energy usage to health and safety, and even the durability of the building. And obviously, it's not going to be very affordable if you're doing those types of things. Going back to the supply leak, I won't set that scenario back up, but when we made the supply leak, you know, the main part of the house went negative. So it's kind of like when we did a blower door, you know, it was depressurizing the house, so anywhere there's holes, air's going to come in. Obviously, the easiest hole for the air to come in now is that little fireplace over there. So all the air's coming down that fireplace first because it's the easiest hole for that air to come in. But also, anywhere there's little holes around windows or anywhere there's holes, it's going to make air come in just like a blower door. And it actually increases the infiltration rate, you know, the amount of air leaking in, because if that house is under that negative pressure, it can actually be pulling in and outdoor air. In the summertime, you know, if it's in a hot, humid part of the country, then it's going to be pulling that hot, humid air into the house, and it's going to have to deal with that. The system is, you know, same thing in the wintertime. If this is negative, then you're going to be pulling in cold, unconditioned air from the outdoors. So basically, having supply leaks or any kind of duct leakage, it's going to affect you know, the way the system operates, your comfort, again, possibly your health and safety. So, you know, duct leakage can be an important thing. You know, when we did the pressure pan, we wanted to find out where the leaks are, that type of stuff. Do what they call combustion appliance zone testing, and that is when we're going into, or anybody's going in to air seal a house or tighten a house up, you want to make sure that when you're doing other things to the house, that your fireplace and your water heater, any of your combustion appliances still draft when you make the tighten the house, when you tighten the house up and so forth. Things that can affect that, besides just duct leakage, are exhaust fans, and like my dryer fan, bathroom fan, kitchen fan, even closing the interior doors. It cuts off the supply air to that main return. If it cuts off that air to that return, it's going to be starved for air, just similar to when I made that supply leak, and it can actually start backdrafting appliances if these things don't have enough return air or enough makeup air for exhaust fans. So I'm going to set up for that, and then we'll go ahead and do some combustion appliance zone testing. Okay, now I've got this thing set up. We're going to do combustion appliance zone testing, and really what I'm doing with this is we're looking at the A side again, and we want to measure combustion appliance zone with reference to the outdoors. That being anywhere there is a combustion appliance, whether it be fireplace, water heater, anything that has basically a chimney that's going to the outdoors, we want to turn on things like exhaust fans, furnace fan, close bedroom doors, and see how it affects the pressures in those rooms with those combustion appliances, and make sure that they draft. Right now the fireplace is on. It's going well. I'm going to turn on my kitchen fan. I don't know if I showed that earlier, but I have a kitchen fan, and it's right directly in front of the Duct Blaster. It's got a little purple light there. You'll see it come on. And the pressure is like minus 0.1, so it didn't change it very much. Now, I'm going to turn on the dryer, and the dryer is all the way, in this case my house, it's in the basement where the garage is. So I'm going to turn it on and see if it affects the area upstairs. I turned on the dryer, it's all the way in the basement. The pressure up here where the fireplace is now went from minus 0.1 to 0.3. The fireplace has actually slowed down the smoke. Now I'm going to turn on the bathroom fan, and we'll see what happens to the pressure in the fireplace. Immediately, as soon as I turned that bathroom fan on, all the smoke rushed into the house. It went from minus 0.2 to minus 1.2 as soon as I turned that fan on. If I turn all those fans off, the fireplace starts working again pretty much instantly. So right now, you know, that bathroom fan seemed to have the most effect. But what we're wanting to do is see what is the worst effect. You know, what's the worst combination? It might be that having all the fans on and then the furnace on and then doors closed might be the worst, which a lot of times is. And then if you have a combustion appliance that you can measure draft on, like a water heater or a regular gas furnace or something like that, then you want to get this zone to wherever the worst case is, being, you know, -3 is worse than -2. Once you get it set under that situation, you actually have the heating system on, and you measure the draft. Being that it measures how well it's pulling the flue gases out of the house. You can actually use the same gauge, a manometer. They have draft gauges that are specifically for that, but the manometer works really well because it measures at the small pressure measurement, and that works really good. So I'll go through and turn all these on one more time, and we'll see what the worst setup is. So I'll turn on the kitchen fan and the dryer, and the more I turn on, the more it starts to slow down the draft. Then we'll turn on the bathroom fan. Now I'm all the way up to minus 1.2, and all the smoke's coming in the house. Now I'm going to turn on the furnace fan, which it changed it a little bit. It went really not much, from like minus 1.2 to 1.3. So now it's changed it a little. Now I'm going to go through and shut the bedroom doors and see what happens to that. Start shutting doors, it starts going more negative. Now it's up to -2.1. And I'm going to shut the last door over here. Now it's all the way up to 6.7 when I close those doors. It jumped that much from closing the doors, because it's the same thing as when I made the supply leak earlier. This return is still looking for that air that's leaking. In this case, it's behind the doors to the bedroom and the bathroom, and that air can't get to it. So it's really putting a negative effect on this house here. In the rooms where it's just got the supply, those rooms are going to be blowing up like a balloon. They're going to be under pressure. Now that's my next thing, is you can actually measure pressures in a room. So those rooms are going to be hot and stuffy. These rooms are going to be cold and uncomfortable because, you know, it's pulling air in through all those leaks and can possibly be causing a health to safety. Right now, there's no smoke going out the chimney. Every bit of it, you know, it's coming in so fast you can't see it again. But as soon as I start opening these doors, the pressures start to lessen and get better. So now I'm back to minus 1.2. I go through and start turning the fans back off, and then the fireplace starts working again. I just have my furnace fan on now. So the main thing is here is you can see how all those different things can affect the house, and you know, it's just by shutting a bedroom door can create a problem. And you know, that's my next thing here. As far as the fans and stuff goes on the model, you can again adjust those to get what readings that you want. Once you get them set and you're comfortable using the model and demonstrations, and you can pretty much just leave those set where you need them. But it's important to do that type of test on an actual house, because
if you go in and make the house tighter and you're not looking at this stuff, and you could actually be creating a problem instead of fixing one sometimes. So it's very important that this test is done, and then once you find out what that worst number is, to actually measure the draft on the appliance. Again, you would do it for everywhere there's a combustion appliance zone. In this case, I would have the fireplace, I would have the water heater in the basement. So all those would be combustion appliance zones. Same thing in the house, anywhere you have those types of wood stoves, anywhere you have those, you want to do that test to make sure that you're leaving the house in a good, safe condition. So I'm going to jump over to doing room pressures next, and we'll talk a little bit about that. Now I have the house set up to do so, what's called room pressure testing. And basically this test is done with the air handler on, and you go through and have the bedroom doors closed, or to those rooms you actually measure the pressure in those rooms with reference to the main part of the house, and sometimes you even measure them with reference to the outdoors. The way I have it set up is to measure the room with reference to the house. That's on channel B. I'll zoom in here just in a minute, we can get a little closer look. But the setup is, it's on channel B here. Is I have my yellow hose. Then that hose goes, I got it just laying across the floor, but it goes into this room here. You can see the door that I'm opening and closing here. So it goes into that room. You can, when you're doing it on an actual house, you just lay that hose under the door. This works, with your air handler on, and then you want to measure the pressure under that door with reference to the main part of the house. Ideally, you don't want more than like positive 3 or even negative 3 if you have returns, in that room. But for the most part, you just have a lot of systems or central systems, and you may have master bedrooms that have 3 or 4 supplies in each one of those rooms, and you can actually have pressures, 20 or 30 pascal sometimes, if you have that type of setup where you've got a master bedroom with 3 or 4 supplies and your main returns out in the hallway. So that room can actually be pressurized like a really big balloon, and be pushing air out if there's any moisture, in the house. And generally if you're getting those types of pressure, the house is pretty tight too, so you could actually be driving moisture into the walls, those types of issues. Sometimes, on a house that you have is starving for air, you may be doing some testing and the furnace fan comes on, all of a sudden you hear doors slam. That's a good indication that it's not enough return air from that room. Sometimes you see dust, around the trim, and stains on the carpet right under the door where air has been trying to, that door stays closed for a long time, and that air is trying to get out, but it can't because there's no return air path. So what I'm going to show you is just how to measure the room pressures, and we'll talk a little bit about if you do have a problem, what you might want to do to alleviate that. So I'm going to zoom on in just a little bit here. I think that should be good. You can still see the room and the gauge at the same time. Now I'm going to turn the furnace fan on. First thing I'm going to do is I'm going to turn the furnace fan on. That door is closed, and we're looking at the B side. Right now the B side reads right around 5-6 pascal. That's what that door closed. So we was talking about that air is going which way. If I take a smoke puffer, another good example for this is take a smoke puffer on that window to this bedroom, for instance, is you can actually puff the smoke, and it's going to be blowing the smoke out. So this is another good visual to do. Right now you see that's like +6. It's jumping around a little bit there. But what I'm going to do now is open this door between the living room and the bathroom, and now the pressure went all the way down to 0. There's no pressure difference there. So like when we was doing a cast test earlier, when we went through and closed those doors, the main part of the house went negative, and the bedroom that we were closed the door to, and you can see here that it actually goes positive. So
we want to be able to relieve that pressure to get it ideally less than 3. You don't want to, on your first, when you first go out the house, just go ahead and say, well, we need to undercut this door by so much, because things are going to change if you're sealing ducts and adjusting the airflow and stuff. So as far as making any corrective action, you want to, when you've done your tightening and stuff, then you want to go in and measure these pressures again after you've done those types of things, and then see where you're at to figure out how much, if any, return air pass that you need to make. On the model here, I had the openings in the walls. I'll zoom back out here just a little. And on the walls here, you can see my hand here, there's a little opening here at the top, and there's one on the other side in the living room, and I can reach through and open it up as well, which it's already open. And I'll open these up, and this is kind of like what making a passive return air. Even though I got the door closed now, some air is going to be able to travel through this hole or grill in the wall here, and then down and then out the grill on the other side over here. So that's kind of like a passive return. You can figure out, how much you need to relieve this room. Once, as I said, everything's sealed and balanced, then you can, easiest way to do that is to open the door. There are charts, I think it's in one of the handouts, is how to, if you open a door an inch on a 32-inch wide door, how many square inches do you need to relieve the pressure in that room. So that's very helpful. And then once you get that less than like the 3, then you can figure out what you need to do as far as, do you need to put a flex duct in the attic from one space to the other, like from the hallway to the bedroom. You can put a flex duct in the attic here. Same thing in the hallway. If this is the hallway, get the air from one side to the other. If you have several bedrooms along the hallway, it might make more sense to put one larger grill in the center of the hallway, and then a flex duct, over to each one of those rooms, so that when those doors are closed, that the air can still return to the main body, and then eventually go back to that hard ducted return that goes right to the air handler itself. So I'm going to go back ahead and shut the door now, which I have, and with those passive returns, and now the pressure in that room is went from like 6 to almost 7 down to 1.6. So that's much better now on that room pressure, and that would be fine. If all those were that good, that would be real good. Again, we still want to make sure that after we do this, that our combustion appliances are still working. So it may require us to have, all the way down to 0 if that's what's causing the problem in our house is that tight. So we need to be able to relieve those pressure problems, and this is just one way to measure it, and you can show it on the house like I have here. You can do the other room if you want to do a demonstration on that. You could also measure, just take this same green hose and put it on the bottom of that port that goes to the room, and measure that room pressure with reference to the outdoors. And that's real important in the fact that if that room is pressurized with reference to the outdoors, like I said before, it can start driving moisture and those types of things right into the walls and start hurting the durability of the house. So that's pretty much most of the tests that that I generally do on the house. I'm sure you could probably think of a few other ones, but that's pretty much the setup and all the tests. I'll probably just do one more quick review on the things that come with the house, and then that'll wrap it up. That's pretty much it. I'm going to wrap it up here with just some of the parts that come with the house. Just recap. Most all the electrical parts are already in the house. As far as all the controls, you just plug it in and turn it on. The Duct Blaster, if you don't already have that, then you can get that through us or through Energy Conservatory directly. Just if you already have one, you can set that up. Hopefully, I gave you enough instructions through the video to get you started on that. If you need more help, just give me a buzz. It's also helpful, at least on the power part of it, to have a power strip, so you can plug in the main cord and the cord for the Duct Blaster, so that's helpful. Things that come with the house, again, the chimneys when we first pulled the house out of the case. We have 3 of these, again, for the water heater, the fireplace, and the kitchen exhaust fan. And it is most of the time easier to put those in before you set the house up on the stand. The other thing here is a car, and they'll vary from different types of cars, but they pretty much always have a car in the model, and they all make the little sounds and all that stuff and start up. So those are just kind of neat. The other thing here is again the stand that I put the manometer in, for the manometer to set in the model. The pressure pan, the little cup to do pressure pan, I'll stick one of those in there. Here's the smoke generating fluid. I have put a refill bottle and a smaller bottle. I mean, you can work out whichever one you want. And then a syringe to put in the smoke fluid with, or take it out of the smoke generators, when you're using it or when you're done. And that's pretty much it. I mean, it's pretty much self-contained, other than the chimneys, everything is laying right here. As far as the gauges, again, you have the 2 types of gauges. You'll have to have one of those to measure the pressure and the flow on the model, so you'll have to have a digital gauge. And the smoke puffer, again, if you want one of the smoke puffers, give me a call and I'll let you know where to get one. But they're real helpful too. So, that's about it. Again, I'm Anthony Cox. I work with the New River Center for Energy Research and Training in Christiansburg. Our phone number here is 540-382-5327. And we have our website, that's nrcert.org. Hope this has been helpful. If you have questions or need more help, just give me a call. Thanks.